Okay, everybody is here. Hi guys, good morning. Shall we start? Are you ready? Hello.
Yes,
Happy
sir.
morning, sir.
Yes, sir.
Yes,
Yes.
sir.
Morning, morning. You should be brisk, isn't it? Okay. So we were seeing redox reactions, isn't it? So we are almost on the verge of completion of the chapter, right? But there is just these small things left out. So we'll see that. So okay, fine, fine. So we are going to see today one special type of redox reaction. Okay, fine. So till now, what we have seen is that in a redox reaction, there are two elements, right? One element was going to get oxidized, the other element is going to get reduced. Till now, that's what is happening. One element, say chromium, getting reduced, iron getting oxidized, right? So like that only we saw, right? Now there can be reactions, right? There can be reactions where there are more number of elements. Okay, there can be say 4 or 5 elements also, right? But in the whole reaction, only one element undergoes oxidation and the same element undergoes reduction, right? And the same element undergoes reduction, right? So let me give you a very good example, right? Say if I take the example of decomposition of hydrogen peroxide, I already introduced you peroxides, right? So what is the formula for hydrogen peroxide, people? Chemical formula. What is it?
H2O2.
Correct, right? So I have H2O2, right? This is my hydrogen peroxide, right? Now this hydrogen peroxide sometimes, like not sometimes, like it is little unstable, right? Because oxygen, I know the most stable oxidation state is -2, right? But I know here what will be the oxidation state. Here the oxidation state will be correct, right? So here the oxidation state will be -1, right? So it is little unstable, okay? So it undergoes decomposition like this, right? How it undergoes decomposition, I'll tell you. So it will decompose to water by releasing oxygen gas, right? It will decompose to water and oxygen gas. Okay, fine. So now I told you that there are reactions where only one element, right? Only one element undergoes oxidation as well as reduction, right? And I think from the reaction you will be able to get whatever I'm saying, right? So if I look at hydrogen, for example, right? If I look at hydrogen, here will be in +1 oxidation state. No doubt. Here also it is +1 and it is in +1 oxidation state, hydrogen. Correct. So hydrogen, nothing is happening, like no reduction, no oxidation, right? But if I look at oxygen, we'll see what is happening, right? So for this here, the oxygen is having a -1 oxidation state, right? And I know in water, this oxygen is going to have a -2 oxidation state, right? And here, what is the oxygen state in O2?
0, sir.
Right, 0, right? Now if you look at it, right, -1 to 0 oxidation, increase in oxidation number, right?
Yes, sir.
And obviously what you're saying, -1 to -2 reduction. Okay, so what do you see here? Oxygen is the one that is undergoing oxidation, and the same oxygen is the one that is undergoing reduction also, right? So these kind of reactions are in chemistry, in technical terms, or what are called as disproportionation reaction. Disproportionation, right? This kind of reactions are what are called as disproportionation reaction. How will you define disproportionation reaction? In a disproportionation reaction, a single element undergoes oxidation as well as reduction. That's the simplest way to put it. Right. Now, how are we going to balance these kind of reactions? Right. We are going to do nothing different. Exactly what we did last class. We know how to balance all these. We know there are certain points to be followed. Right. So exactly same things we can follow here. right? Now let me take one example. We'll see how to balance them, right? And one more thing is we have something called as conproportionation reactions also. Conproportionation, right? Which is nothing but the exact opposite. If I just take the reverse reaction of this, H2O plus O2 giving H2O, right? That is my conproportionation. So this proportionation, one element on this side gets oxidized and reduced on the product side, right? And I should have two, like say two numbers of the element in the reactant side, and that will get oxidized and reduced simultaneously in the product side. So that is my conproportionation, right? So if you can understand disproportionation, the reverse reaction of that is what is my conproportion. But here again, in both the things, what is common? There is one element which is getting reduced and oxidized, not more than that, right? Okay. Now let me take some examples and we will go about it, right? Okay. So you know it. Right. So let me take this reaction. I have Cl2 giving Cl minus plus ClO3 minus. Yeah, ClO3 minus. Right. And I want to balance this reaction. Right. Exactly what you did. The same thing we will do here also. Right. Now, what is the first step? First step is writing the reaction. And again, I have to tell you which medium is it. It's going to happen in alkaline medium or basic medium. Right? So it is given in the question that this reaction is happening in basic medium. Okay, fine. So exactly what we did, the same things we'll do, right? So what is the first step? What is the first step, people?
Finding oxidation number.
Oxidation number.
Okay, obviously finding oxidation number is the first thing, right? Okay, so but here you don't have to use that, because you know why we did that in the first place in the previous reaction is because I have to understand which is undergoing reduction, which is undergoing oxidation. Correct? Here there is only one element, right? So yeah, oxidation number has to be calculated, but we can fine, we will do it, not a big deal. So here it is 0, for this it is -1, right? For ClO3 minus we'll calculate, so x minus 6 equal to -1, so x is +5, right? So do you see a disproportionation reaction? Yes, I have 0 to +5 increase in oxidation number, oxidation, 0 to -1 reduction, right? Okay, fine, this we did. I know what is the next step. Next step is
Writing down half reaction.
correct, writing down the half
With
reaction,
halves.
right? Correct. Now here also I have two halves, but the only thing is I have both the element in the same, and I write exactly what it is, right? So now if I write the oxidation half reaction, how will I write? Cl2, right, is becoming ClO3 minus. Yes. Okay. Fine. Now, first step before even attempting to do anything, what should I do here? Tell me.
2 ClO3 minus.
Exactly. Very good. So I have to put 2 ClO3 because here I have 2 chlorine atoms. Here I have only 1 chlorine atom. That is the first step. Wonderful. Right. Now, I have to calculate the number of electrons lost. Correct. Okay. Now, what I see here, it's 0 to +5. Right. 0 to +5. That means 5 electrons have been lost. Right. 5 electrons have been lost. So I am going to put 5 electrons here. Am I right?
No, sir. It should be 10 electrons.
Correct. So it should not be 5 electrons, people. It is 5 electrons per chlorine atom. For 1 chlorine atom, it is 5 electrons. So for 2 chlorine atoms, it should definitely be 10 electrons. So it should be 10 here, 10 electrons. Yes. Okay. Now that's my oxidation half reaction. Now going back to reduction half reaction, I know what is happening. Cl2 is becoming Cl minus, right? And again, as we did in the last time, here also you have to put a 2 in Cl minus. just to make the number of atoms of chlorine to be equal. Done. Okay, now I know 0 to -1, there is 1 electron accepted, right? 1 electron accepted per chlorine atom again, right? So how many atoms totally?
2 electrons.
2 electrons, right? So I have to put 2 electrons in the reactant side. Okay, now what is the next step? I have to make sure that the number of electrons lost and number of electrons gained are equal by suitably multiplying by factors, right? So now obviously what I can do is multiply this by 5, right? Multiply this by 5, what will happen? 2 electrons into 5 will become 10. Already I have 10, so when I add these two, number of electrons will get cancelled, right? So done. So now I'll add these two equations now. So I have, okay, how many total Cl2s? Here I have 1 Cl2, right? And here I have 5 Cl2s. So 1 plus 5 will become 6 Cl2s. No problem, right? 1 Cl2 is already here, and I already have 5 Cl2s here in the second half reaction, so totally making it 6 Cl2s. Okay, fine. Next, oops, moving on. I have, sorry, giving 2 ClO3 minus, right? And I have how many chlorides? I have
10
5
Cl
into
minus.
2, 10 Cl minus. Done. That's it. Okay, fine. Now what is the last step? What I have to do after this?
Adding OH minus and H2.
Okay, what is that process called as?
Balancing charge.
Okay, so this charge balance, right? So I have to make sure that the total amount of charge in the reactant side and in the product side are equal, right? And for that specific case, they have given us it is going to be basic medium, so I'm going to add OH minus on the appropriate side, right? Okay, fine. So here in the reactant side, the total charge is 0, people. There are no charges. It is all only 1 Cl, 6 Cl2s are there. No charge, 0. Going back here, I have 2 into -1, -2, 10 into -1, -10. So I'm going to have -12 for this thing. What is that? -12 for the product side charge, right? So obviously I have to add OH minus in the reactant side, and obviously I have to add more and more negative charges to the reactant side, so that 0 becomes -2. So obviously I have to add 12 OH minus. I have to add 12 OH minus on the reactant side, right? Okay, and obviously I am going to have how many water molecules? How many water molecules? 12 water molecules.
6H2.
6H2.
Okay. 6H2O. I need to have 12 H2Os, right? And I have to, okay, wait. Now, here I already have 6 hydrogens. See, 6 oxygen if you see, right? In the product side, I already have 2 into 3, 6 oxygen atoms, right? And in the, in the reactant side, I have 12 oxygen atoms. So I just have to add 6 more oxygen atoms on the product side. So obviously it should be 6 H2O. Please understand this. Again, I repeat what I'm telling. Here I have 12 oxygen atoms, right? Now in the product side, I see how many. So here I have 3, here I have 2, totally 6 oxygen atoms on the product side. So I just have to make sure that I add 6 more oxygen atoms on the product side. So I added 6 H2Os. Done. This is the balanced equation. But still.
You can simplify it, no, sir?
Exactly, right? I'll be able to simplify because you can see 6, 12, 2, 10, 6, all are divisible by 2, right? So if I simplify this equation, can I say it is 3Cl2 plus 6OH minus gives how many? ClO3 plus 5Cl minus plus 3H2O. This is the last final answer. Okay, so if you just notice here, for disproportionation or whatever the type of reaction, the steps are exactly same. Okay, so let me see if I can find one more example for you for going for this. One second, people. I'm just searching for a question. Okay, I got it. Okay, I have P4 or wait, I'll write it like this. I have H3PO3 giving H3PO4 plus PH3. Okay, I have this reaction with me. Right. Cool. So I have to balance it. Right. Now let me see whether it's a disproportionation reaction first. Obviously, I think you will be able to understand. So for hydrogen, all the places it's +1. So hydrogen, nothing is changing. And oxygen also nothing will be changing because oxygen will be -2. Here also it's -2. Right. So the thing which is undergoing disproportionation here would be phosphorus. Right. P. Right. So let me calculate what will be the oxidation number for phosphorus in all these cases. So you can see that I can have 3 plus x minus 6 is 0, right? So I have x to be equal to +3. So here for phosphorus, it is +3 oxidation state. Okay, now going back here, 3 plus x minus 8 is 0. So I can tell x is +5. So here for phosphorus, it is +5. Okay, now here I have x plus 3 is equal to 0. So x is +3. Ooh,
-3.
oh, sorry, -1.
Yes, please, sir.
Yeah, correct. So here I have -3 for this phosphorus, right? So again, you can see +3 to +5 oxidation, and you can see +3 to -3 reduction. Yes, again, a disproportionation reaction. Go for it. Balance it. I'll give you 2 minutes. So guys, one step, last step you don't have to do. That is your charge balance.
You don't have to do no, sir. It's
Correct,
neutral.
because all are neutral compounds. Right. reaction is easy only. If I do it, okay, first half reaction, let me take H3PO3 gives H3PO4, and this is my oxidation reaction. I don't have to multiply anything because there is one phosphorus atom, one phosphorus atom. Don't worry about it. Okay, and how many electrons? +3 to +5, 2 electrons. Okay, fine. Next, H3PO3 becoming TH3. I have +3 to -3. Right? I have +3 to -3. How many electrons?
Electrons.
Correct. It should be 6 electrons. -3 to 0. So that's 3 electrons. Again 0 to +3. Again 3 electrons. Totally 6 electrons here. Done. So what I have to do, I just have to make sure the number of electrons lost and gained are equal. So obviously I'll multiply the first reaction by 3 and then just add it. So that's it. So you will be getting, so totally 3 H3PO3 is there here, and there is one more H3PO3 here. So totally how many? 4 H3PO3, right? And I have giving 3 H3PO3, sorry, PO4 plus how many? 1 PH3. That's it. This is the balanced equation. And you don't have to do charge balance because no, there are no ions at all. They are just all neutral compounds, both on the reactant side as well as product side. Right? So how many of you got this?
I got it.
Okay.
Got, sir.
Okay. Anybody else? So I should assume that.
I got, sir.
Okay, very good. Right. Fine. Cool. So yeah, people, that's about disproportionation and counterproportionation reactions. Right. What I wanted to ask is, do you have redox titrations in your syllabus? Did they teach you anything in titrations?
Sir?
Right? Like there are something called as, we already did titration, isn't it? Acid-base titrations we did in the first chapter, right? So like that, we have something called as redox titrations also. Do you have it in syllabus? Or did they in
Not
school? Did
sure,
they teach you?
sir. Not yet, sir. They're still they have
Sir,
take
can you
substance.
repeat?
What I'm asking is there anything called as redox titrations? Is there anything like that did they teach you in school?
Sir, in our school, they are still in disproportionation, this thing only, sir.
Now only they have finished this thing,
They are
half
now only
reaction
they
method,
finished.
sir.
Oh, okay. Fine. Anyways, there are certain things a little important. We don't have to look into the titrations. We know what is titration, isn't it? Okay. First, let me recollect. Right. I will remember. I am sure that you will not remember. Let me see. I'll ask you. Do you remember what is a titration? What is that? What is it involving? Titrations. We saw it in first chapter. You don't remember? Okay. Maybe if you would have gone to labs, if you've gone to your school, maybe by this time you would have even done the experiment. Maybe that you would have remembered, right? So anyway, people, titrations are techniques for finding unknown concentration of a solution, right? So I have a beaker, right, in which I know what is there, but I don't know how much is there. I want to find what is the concentration, molarity or normality. Oh, normality. Did you remember the term normality?
Yes, sir.
Oh, okay, fine. I think I would have thought you. Anyways, so the thing is, what I was telling. So titrations are techniques to find the concentration of, unknown concentration of a solution, right? So if you can remember, there was something called as pipette, burette, titration flask.
Yes, sir.
Right. So guys, what you do is today, if you find time, go back to the first chapter, try to access the video in which we talked about titrations. Okay.
Sir, does titration come under applications of redox, sir?
Not applications of redox.
No, because we don't have applications of redox reaction.
Okay. Fine. So I don't think you have redox. You don't have redox titrations, I guess, because like it is little on the tougher side. I don't think it is there for you in CBSE level, but again, but for our competitive exams, yes, it is there. That I know. Okay. So anyways, so I think if that's the case, if you don't have titrations and the chapter is completed, okay, this chapter is over, okay. But this is only little things I'll tell you, okay.
Sir,
Yeah.
ma'am taught us to balance the redox reaction in two ways, sir. This is the half reaction method and this is another method, sir. Can you like brush up that other method also because it's little
Why
difficult?
not? Why not? Why not? Why not? Easy, right? So let me take any reaction for that matter. Like say I have MnO4 minus plus Fe2 plus gives say Fe3 plus Mn2 plus. Can I take it as such? Okay, Mn2, right? Mn2 plus Mn, it will become Mn. Okay, fine, good, right. So let me use the other method. The other method is what is called as your oxidation number method, right? So it is nothing big, exactly what we do in just a different way, right? So you are just not going to write any half reactions. You are just going to use this reaction only, and it is going to look clumsy, and that's why I didn't use it. Very simple, like there is nothing changing. So again, this is the first step, writing the reaction skeletal equation, right? And then write down the oxidation numbers. So oxidation number I know is here is +7, +2, +3, and +2. No problem. Again, same thing. Identify which is getting oxidized, which is getting reduced. So I know manganese is getting oxidized. And here, the only extra thing you're going to do is you're going to make sure the number of electrons lost or gained is also included in this step,
Sir, it's
right?
getting reduced
So,
now, sir.
Manganese is
sorry.
getting reduced.
Yeah, sorry. It's undergoing reduction. Okay. So now you have to include the number of electrons, in this case, gained also in this arrow mark. Okay. So now I know how many electrons are lost. Gained, I have 5 electrons here. Okay. Now, for next is Fe2 plus to Fe3 plus. I know it is oxidation, right? And I know there is just 1 electron lost, right? Now again, this step you would have done in 2 different steps. Like basically, you would have done the half reactions and then return the number of electrons. Just that I'm writing it here itself. Okay, fine. Next thing is again the same exact step. Go for balancing the number of electrons lost and number of electrons gained by suitably multiplying with the factor. And obviously, I have to multiply this by 5, right? And if you multiply this by 5, I will put 5 here and 5 here. Like basically, to which for which element, or for which 2 species you are drawing the connection, and whichever you are multiplying in the connection, that has to be reflected in the reaction also, right? So I multiply this connection by 5, so I have to put 5 Fe2 plus and 5 Fe3 plus. That's it. After the charge balance is similar in both these methods. That's it. You understood?
Yes, sir. Thank you, sir.
Very simple. But what is the problem is, like if I go to disproportionation reactions and all, this method is like little complex, right? So if you want to try to do it, we'll try to do the same example here with this. So I think the example I gave you was Cl2 becoming Cl minus plus ClO3 minus, right? It is actually a little clumsy. I would really not suggest you to go by this method, especially for this kind of reactions, because we'll see how it looks. Okay. So again, doing the first step, 0 minus 1 plus 5. So 0 to plus 5, 5 electrons, right? Oh, wait, again, there's a problem. It's not 5 electrons. 1 Cl to become Cl plus 5, it is 5. So totally it is 10 electrons, right? See, like this you have to calculate it. But there what we did, first itself we multiplied 2 on ClO3 and then we individually calculated. For 1 atom, it is this much. For 2 atoms, how many? So like that you had a chance to calculate, but here you have to directly put it, 10 electrons. Okay, fine. And here, right here, I have totally 1 electron lost per atom. So but I have 2. So I'll put 2 electrons. Okay. So now I know I have to multiply this by 5, right? So here I'll put 5 and here I'll put 5. But again, it's not balancing. There is some problem. What is the problem? 5, I think I should not put.
Sir,
Ah.
in school they told for disproportionate reaction it's better to use half reaction methods.
Yeah, definitely. That's what even I'm telling. For disproportionate reaction, please use half reaction method. I would really not suggest this because sometimes what you have to do is when you multiply, like see, this belongs to this also, this also. So like a lot of complexities will come, right? So I would prefer just know the methods, just know the method. But in your exams, they will not ask you, by this method only you have to solve. They'll not ask you like that. They'll just ask you to balance the reaction. Then you can use any method you want. Okay, so fine. This we are not doing. Okay.
I
Yeah.
have a doubt. It's a question
Yeah.
they gave in school, sir.
Tell
But
me.
when I tried, I'm not getting the exact answer.
Tell me.
It's Cl2O7 plus H2O gives ClO2 minus plus O2.
Cl2O7 plus H2O gives?
ClO2 minus plus O2.
Oh. You have to balance this, huh?
Yes, sir.
Okay. So for now, I'll remove the water molecule. I don't need that.
H2O2, sir, peroxide.
Oh, peroxide. Okay, then we have to take it. Okay, fine. H2O2. How is it that I have? This question is wrong. I think they misplaced something here, right? So I think it should be H2O. If it's H2O2, I don't think this can be, because how am I telling you it's wrong? Is because for Cl2O7, if I calculate 2x minus 14 is 0, so x is plus 7. Oxygen here is minus 2, here it is minus 1, right? And here I have 0 for oxygen, and for oxygen here it is minus 2. For chlorine it is x minus 4 equal to minus 1, so x is plus 3. So what you see, there are 3 times oxidation and reduction is happening. One reduction is for chlorine, right? And oxygen is undergoing disproportionate reaction also. Oh, either it should be a wrong question or we'll try to solve it. If this is how it is, we'll try, right? Okay, we'll see what is it. Right. So let me write the first, but okay, let me try. Right. So Cl2O7 becomes ClO2 1 minus. So let me put 2, right? So here it is plus 7 to plus 3. Obviously, there is for 1 chlorine atom. Here I have 2 chlorine atoms. So it is 4 electrons, 8 electrons has to be accepted. Done, right? Now, if I take H2O2, I have to include this also, that also. ClO2 minus plus O2. Here it is minus 1. But again, I have to write this, right? This has 2 separate reactions there. Okay, let me write it. Okay, wait, let me write this again. So I have Cl2O7 plus 8 electrons gives ClO2 minus, and I'll put a 2. Okay, now I have H2O2 becoming ClO2 1 minus. This is one again another reaction, right? So I know here it is minus 1 and here it is minus 2, and there are 2 oxygen atoms only. So 1 oxygen atom becoming minus 2, for this it is 1 electron, right? But there are 2 oxygen atoms, and you have to say that there are 2 electrons accepted. No problem. For 1 oxygen atom, 1 electron. 2 oxygen.
Sir, doubt. How is it 8 electrons, sir?
Here it is plus 7. Correct. Plus here plus 7 to plus 3.
Okay, so 2 into 4.
But,
okay, yes.
Correct. There are 2 chlorine atoms. That's right. Okay. Right. So next, again same H2O2. is becoming O2. So I have again -1 to 0. -1 to 0, I have 1 electron, but here I have to have 2 electrons. Okay, right. So I have to do something to these so that there are no electrons in all of. When I add them, there should not be any electrons. If that is the case, so totally 10 electrons in this side, and okay, I think if I multiply this by 5, is it not? If I multiply this by 5, in the product side I have 10 electrons, and here already I had 10 electrons in the reactant side. If I add these two, correct? If I add these two, 8 plus 2 becomes 10 in the reactant side. So in the product side also I need to have 10. So I multiplied this reaction by 5.
Okay, sir.
Right? So if I add it, so totally I have how many? 1 Cl2O7 and 5 plus 1, 6 H2O2. And I have how many ClO2s? 2 plus 3, 3 ClO2s. Oh wait, product side. 3 ClO2 minus, and what else is there? O2, and I have 5 O2. That's it. Right? And obviously I have to go for charge balance. Did they give you any medium?
Alkaline medium, sir.
Alkaline medium. Okay. So there is no charge here. I have 3 minus 3, right? So I need to add OH minus. So obviously I have to add 3 OH minus here, 3 OH minus here, and I have to segregate it with water also. So how many oxygen? Let me calculate. 3 oxygen, 10 oxygen, plus 12, 22. 7 plus 3, 10. 10 plus 12 is 22 oxygen atoms. Here it is 6. 6 plus 10 is 16. So I need to have 6 more H2O. Yeah, this is the balanced equation.
Okay, sir. Understood.
Right? But I don't know whatever I did is correct or not. We got the answer, right?
I'll ask my ma'am.
Yeah, let's take a picture or a screenshot or something of this and then show her if this is
I wrote down, sir.
You wrote down. Very good. Cool. Right. So yeah, I think this is the toughest question which can be asked if this question is correct. Okay. Right. So any more doubts, people? Do you have any other doubts in chemical bonding? Do you want me to teach anything again? We'll use this time. We have almost like 15 more minutes. Not only a chemical bonding, any chapter we have completed some basic concepts of chemistry, atomic structure, chemical bonding, periodic table, and redox reactions. Right.
You can give a brush up on hydrogen bonding, sir. That
Yeah,
intramolecular
why
and
not?
metasubstituted object.
Cool. Right. So we know okay. So we know hydrogen bonding comes under secondary types of bonds where there is not an actual bond, but still I would say a partial bond is what is happening, right? So it is again a very good example of dipole interactions, isn't it? So one dipole, I know what is a dipole, right? The dipole is a equal and opposite charge separated by a distance, right? Okay. So for that, that's a special case. Hydrogen bonding is a special case of dipole, right? So and again, I know that for hydrogen bonding to happen, right, I require 2 things. One is what is called as your hydrogen donors. Another one is what is called as your hydrogen acceptors. If these 2 are present, yes, hydrogen bonding will happen, right? I know what is the condition for something to be a hydrogen donor, right? So the hydrogen atom should be attached to a highly electronegative element, right? The hydrogen donors, how it should be? The hydrogen
Attached
atom
to
should be
highly
attached to a
electronegative.
highly electronegative element, and only namely 3: oxygen, nitrogen, fluorine, right? So if you either see a FH bond or OH bond or NH bond, that can be hydrogen donors. Okay, now hydrogen acceptors, there's only one condition: they should have presence of lone pairs on the particular molecule. If they have, yes, they will be able to accept hydrogen acceptors. Okay, and like I'll be able to represent it like this. If I have water, for example, I have del minus and del plus, another oxygen atom, I mean another water molecule having not, I'll not tell it, you can see, you will be able to regard hydrogen bonding in two ways, right? One, you can say that I have a del negative here, so I can have an interaction between these two positive charges and negative charges, or you can tell that the interaction is actually between this del positive and the lone pair on oxygen. Either way, lone pair again is a negative charge, right? So this is what is my hydrogen bonding. Again, between this del positive and this oxygen negative, I can have. So this is what is your hydrogen bonding, right? Now, as you asked for it, I have two types of hydrogen bonding. One is what is called as your intermolecular, and another one is what is called as intramolecular. And I think I gave you an example, good example, inter-school and intra-school competitions, right? Inter-school means many schools will participate, right? And intra is between only your school students, right? So same thing here. If I say intermolecular hydrogen bonding, I should require two molecules. Same molecule or different molecule, doesn't matter. Here I have two H2O molecules. Again, two molecules. If I have one H2O and one alcohol, again it is called as your intermolecular hydrogen bonding only. It doesn't matter whether I have same molecule or not. I should have two molecules. That's what is important. So this is an example for intermolecular hydrogen bonding, right? And intramolecular will generally happen in organic compounds. I gave you a compound like this, if you can remember. I have a OH and say I have an NO2, right? So this is benzene ring basically. Okay, in this benzene ring I have, you know, there are something called as functional groups, alcohols, aldehydes, ketones, carboxylic acids, all these. And one of them is nitro group. This NO2 is going to be called as nitro group, right? Now, instead of having between two, if I take two molecules, yes, I would say that some amount of hydrogen bonding can happen because I have a OH bond here and this oxygen has a lone pair. Yes, accepted, right? But here there is an easier way of undergoing hydrogen bonding because you have a OH bond and this oxygen atom has a lone pair, right? So I can say that there will be an interaction between this hydrogen and that oxygen. This, again, you see, do you have two molecules? No, there is only one molecule. But inside that molecule itself, I have hydrogen bonding. So this is an example for intramolecular hydrogen bonding, right? And obviously, intermolecular hydrogen bonding is stronger than intramolecular hydrogen bonding, right? And we know what are all the consequences of having hydrogen bonding. Boiling point will be increased, right? Solubility will be increased, right? So all these are the consequences.
Understood, sir.
Right? Okay. Any other doubts, people? From any chapter? Fine. So the next chapter we'll be starting is gaseous state. Okay. So for next three chapters, okay, it is going to be full numericals. Right now, periodic table. This one, that is chemical bonding as well as redox reaction, you wouldn't have any numerical as such, right? But in the coming chapters, especially in gaseous state, equilibrium, those two chapters, you are going to have a lot of problems and actually good concepts to understand also, right? I would say gaseous state is not that difficult, right? But it is interesting as well as the problems are very good, like it's easy to do, right? But equilibrium, thermodynamics, wonderful chapters. For me, if you ask me which is my favorite chapter in 11th class, it is going to be thermodynamics, right? So anyways, we'll see we'll see it when it comes, right? But again, a beautiful chapter, right? Beautiful chapter, beautiful problems, and you'll be able to solve them all. And after that, we'll be going for organic. Okay. So a new thing, like you have studied, right, in your 10th class, but that is not even 0.00001% of what organic chemistry is. Okay. So it's a very huge, a vast area, right? And which will continue in your 12th also, obviously. And if you're not going to I'm telling you, for the, not only this chapter, if you really are not going to concentrate on these 11th chapters, if you you don't understand, at least you don't have to have master everything, but you need to know what and all we studied, like what are the basic concepts, right? If you don't know that, when I go to 12th, you can get marks. Marks anybody can get, but will you understand and get marks? That's a question mark. Okay, fine. So you will be writing a test very soon on periodic table, because we missed periodic table. We wrote, I think the last test we wrote was atomic structure. Before that we wrote more concepts. There's some basic concepts. So after, like, and I think some days we'll be writing periodic table, and after that you'll be writing 3 tests. As I told you, you'll be writing 3 tests for your chemical bonding, and then we'll come for redox reaction.
Sir,
Okay, yeah.
sir, this Sunday we don't have any test, sir.
This only?
This Sunday, sir, we don't have any test, sir.
No, they didn't inform you anything, right? This Sunday? No, they're not this Sunday. Maybe next Sunday.
Okay, sir.
Okay. Right. So, guys, how many of you have enrolled for JEE? Has anybody enrolled from here?
Me, sir.
What's your name, Kanna? I didn't see who was talking.
Sasmit.
Oh, Sashmit. Okay. Anybody else?
So I did for NEET.
Okay, again, what's your name, Kanna?
Pranav, sir.
Pranav. Okay, Pranav. Okay, neat. JEE. Nobody else? Rohan?
No, sir, I don't have plans.
You don't have plans. Okay, so what are you planning to do after 12th?
I am not sure.
Okay. No issues at all. Cool. So I think if you don't have any doubts, we can wind up, people. Is there any other doubt you want me to clarify? Okay, fine. Till then, we'll meet again day after tomorrow with a new chapter. Right? Till then, thank you. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you.